This is the screencast for section 5.2, example 4. We're going to set up a difference of squares. We've already done this in a few problems, but this time it's a little bit different in that we don't have a common denominator we're trying to achieve. We are just creating a difference of squares. So if I look at both sides of the original problem, I mean, it's kind of hard to decide which I want to start with. Do I want to start with the left or do I want to start with the right? And sometimes it doesn't matter. And in this problem, it doesn't matter. Both sides would be, I think, an equal amount of steps. I am going to choose to start with the left. If you were going to do the right, you would create a difference of squares in the numerator. I'm going to work with the left and create a difference of squares in the denominator. So I'm going to create this difference of squares. I see cosine of t, I see 1 minus sine of t, but there's nothing I can do with that. 1 minus sine of t is not cosine of t. 1 squared, or 1 minus sine squared of t is cosine squared of t, but we don't have a 1 minus sine squared, so I need to create that. So I'm going to leave the numerator, 1 minus sine of t in the denominator, and now I'm going to just multiply by 1 plus sine of t over 1 plus sine of t with my equal sign. Now, I have not changed the value of this at all. I have multiplied by something over itself, which is 1. I haven't changed this, I've just kind of unsimplified it. So now in the numerator, I have cosine of t times 1 plus sine of t over, and here's our difference of squares, 1 minus sine squared of t. Now on, let's see, 1 minus sine squared of t by our Pythagorean identities is cosine squared, so I'm going to leave cosine of t times 1 plus sine of t all over cosine squared of t. Now, I'm keeping the end result in mind. I could have distributed the cosine, but I didn't because I see on the right side I'm supposed to have a 1 plus sine of t. So why would I distribute in when I already have that grouped together? Now, this cosine and one of the cosines in the denominator cancel, so I have 1 plus sine of t over cosine of t. Equals itself. The now try problem, example number 39, does have a situation where I can work with the left side or the right side, but the left side seems to me a little bit more complex because I know I can find a common denominator here. So on the left side, I see that on the right side, I see that my goal is going to have a denominator of sine of t. Well, this one already has sine of t as the denominator. So I'm going to create a difference of squares, not a common denominator, just a difference of squares. So I'm going to give that first term a 1 plus cosine of t in both the numerator and denominator. Again, this term right here already has the right denominator that is my goal expression. So I'm going to leave that and see if I can figure out a way around working with this term. On the, this first term, we have the sine of t. I'm not going to multiply this out yet. I probably will eventually, but right now I'm not. And then a denominator, 1 minus cosine squared of t minus 1 plus cosine of t over sine of t. Now my denominator, 1 minus cosine squared of t, is sine squared. Again, not multiplying out the numerator. I'll multiply it out when I see that that's going to help me. Oops, I forgot to put over sine squared. Now so the sign of the numerator cancels out with one sign in the denominator. So I have 1 plus cosine of t over sine of t minus 1 plus cosine of t over sine of t. Well, maybe you picked up this, but I'm just thinking to myself, 1 plus cosine of t minus this is 0. But this is supposed to be a plus sign in all of these. Oops, my bad. So now I have 1 plus cosine of t plus 1 plus cosine of t, which is going to be 2, plus 2 cosines of t, all over sine of t, which if I factor out a 2 in the numerator, I get 2 times 1 plus cosine of t over sine of t, which is exactly what I was looking for. This extra example I want to show you has a difference of squares on either side, but now one is in terms of secant and tangent, and the other one is in terms of sine and cosine. I think it's easier to start with the side with secant and tangent because it's easy to change those into sines and cosines versus the other way. So I am going to work with the left side first. I'm going to, let's see, first change secant to 1 over cosine of x plus 1, and then change tangent to sine of x over cosine of x. Now I see in the numerator I have a cosine of x in the denominator, and in the denominator I have a cosine of x in the denominator. So I'm actually going to multiply both the numerator and denominator by cosine of x. So in the numerator, cosine of x gets distributed to both terms. So I have cosine of x over cosine of x plus, and now cosine of x. In the denominator, I'll have a cosine of x with the sine of x over cosine of x. Those cosines cancel, those cosines cancel. Now I have something a little bit cleaner to work with. 1 plus cosine of x over sine of x. Now I'm trying to get sine in the numerator and 1 minus cosine in the denominator. So I have a 1 plus cosine in the numerator. I need a 1 minus cosine in the denominator. So I see a difference of squares tie-in here. So I'm going to multiply both the numerator and denominator by 1 minus cosine of x. So in the numerator I now have my difference of squares, 1 minus cosine squared of x. And in the denominator I have sine of x times 1 minus cosine of x. 1 minus cosine squared is sine squared of x. So that will cancel out with the sine of x in the denominator. And then my final step after I shrink this down a little bit will be just to cancel out that sine of x in the numerator with the 1 in the denominator. So I still have a sine of x remaining in the numerator, but now my denominator is only going to have 1 minus cosine of x, which is exactly what my goal was.